Hello everyone. In this video, we will do exercise in LabView to make a program that can measure the dimension of the object using camera. So we will practice with this video, and for the program, I will demonstrate first, so you can see what the program that we will make in this video. This one. Okay. In this video or in this exercise, we will measure this object, diameter of this object using camera. So we already uh, create, I already create this program, and I will demonstrate for the first time, and I will start. Okay, for the first, we should capture the object using camera. My camera, I have a problem with my camera, so I need to uh, configure the contrast for my camera. Maybe uh, this error only for my uh, laptop or my computer. So, and I like again. So this is the object, and I will use the rectangle ROI here and set this ROI as a set area 1. I will push this button. So this rectangle will be saved in ROI 1. And after that, for ROI 2, I use a circle ROI like this one, like this, and we can fit with the object and also the small circle in the inside. And I set this ROI as a set area 2. Okay, so for the set area 1, we already save with a rectangle ROI. We can see in the ROI descriptor, we set as a rectangle, and for ROI2, we set as a annulus. Annulus is just like a circle like this. And then we can measure the diameter of this object using ROI1. So I will tick ROI1 active. Okay, and I will capture again with capture button, and the system will measure the diameter of this object. But when we not yet set the real distance, so we can calibrate. We can calibrate first for the real distance for this object is for diameter is 20 millimeters. So we set this real distance with 20 millimeters, and we can calibrate now. Okay, and x divided by y already set. This is the calibration value. With the 283 pixel, we can get the 20 millimeters. So after we calibrate, we can capture again. And then diameter with rectangle ROI is 20. And after that, we can compare if we use ROI as a circle shape. Okay, to show the circle ROI, we can untick the ROI1 and activate the ROI2, and we can capture again. So the edge of circle object we already create, and this from this we can see that with the ROI circle we see that the diameter, the measurement of the diameter is 20.6. If we use a rectangle ROI, the diameter is 20.2. And we can also activate both of ROI here with activate all ROI1 and ROI2, and we can capture again. And we can see for the first ROI with the rectangle and the second ROI with the circle edge. This is the program that we will make in this video. So we can compare the measurement from the rectangle ROI with the circle ROI. After this, we will go to the block diagram. So this is the block diagram that we will make to create the program to, to compare the rectangle ROI and circle ROI uh, that can be used for measure the diameter of the object. We will create from the scratch how to build this block diagram. Okay, I will I will create the new project and create from the scratch for the block diagram and also for the uh, graphical user interface like this. Okay. Okay, you can see it like this. Okay. This is the new project that we will create for the program, and now we should prepare the OK button, and we can change the name with start, and this is for I set this capture here, and we need one more for OK button, and this button is for calibrate. So I change calibrate here, and then okay, move to the right, and I need a boolean also with the push button here to set the ROI, set area one, and we can right click to mechanical action. I use latch until release, and also for the second push button, to set area 2. Okay. We set area 2 and setting for mechanical action with latch until release. Okay. Yes. And then we need to use what is this? For the user control system with a boolean and system checkbox like this. Okay, and we set ROI1 active. Okay, I1 active, and also system boolean and checkbox again for ROI to if yes if okay, and then we need to set the image display here. Okay, image display, and also we need to show the diameter numeric as an indicator. This diameter diameter with rectangle rectangle ROI. Okay, and also we need one more for diameter diameter with circle ROI. Okay, and then as indicator, I set pixel, and we need more as for calibration X per Y, and so for the real uh, real diameter, we can measure with using a ruler. So we can set numeric control here. So I change to real distance or diameter. Yes, in millimeters. Okay, and we after this we need to input the ROI descriptor. Maybe ROI descriptor here, vision, mm, image vision control ROI description 1 and ROI description 2. I change with ROI item 1 and ROI item 2. There. So for the user interface, we already done like this. We have start, calibrate, set area 1, area 2, ROI 1 active, ROI 2 active, and the numeric 4 as a indicator and 1 as a control. After finish in front panel, we move to block diagram here. We can arrange the flow of the program here, and before that we should prepare the we need camera input with vision motion and motion with and image dx we I image utility image management, yeah, I am create. We can copy, make two. For the first component, this one is for the RGB image. Okay, so we can create This one is image, and the type is RGB. And for the second, we can create a name is black white or one channel image, and then get constant for this grayscale. After this, we need to uh, input our camera uh, component with this one open, and then open from my camera. You can choose where is your active camera, or camera 0, camera 1, or camera 2. We can change later. After this, we should prepare configure configure the camera here, and also grab the picture. Okay. Okay, and we need structure, while loop structure. Here we can make the big one. Okay, and then we set area 1 with the structure base here. This is for the set area 1 push button. If the set area 1 push button click is click, so the ROI, we can use the from image, and ROI, create property node, and ROI, we set this, and also we can insert the ROI item 1 here, and we set this. Okay, we change to the indicator. Okay, so like this. And also for set area 2, we use case structure with the set area 2. If set area 2 is click, okay, is so the condition is true, and then we need ROI again from the image display, and right click. After that, create a property node with the ROI, and send to ROI item 2. Right click and change to indicator, so we can connect with the image like this. After that, we need to make the calibrate function, calibrate push button function structures, case structure, this one. And for the calibration, we can use the calibrate button. If the calibrate button is clicked, so the condition will be true. After that, the real distance here will be divided by the pixel. Okay, divided by the pixel. Okay, so from this we create the local variable here. So, and for the local variable, we can change to read. So it we can divide it the value, and it will be and we save to X by Y here. Okay. And then for the main function with the start button here, with the start button, so we need a case structure. Sorry, before we move to case structure, we need to activate the control to stop here, and we prepare for the case structure. Okay, here case structure, and then we need vision motion to extract one channel from the RGB image. Okay, because for the image processing, it's simple to use only one channel, and then we can only process one channel to uh, measure the object. So for this, we use image processing, color processing, and then no, machine vision. We can of vision utilities, color utilities, and extract single color plane. Okay, we move this. And for the image source, we get from RGB. So we already create the variable for the RGB image and for the black and white image. So for the RGB image, this is we use this to save the image from camera capture. Okay, so we can set in the image in. Okay, after that, for the image out, we can connect it to the extract image source in extract single plane. And for the destination, we can use from black and white uh, component here. Okay, and then after this is the module for extract single color plane. So for the explanation, uh, IMAQ extract single color plane defines the color plane to extract. So can we from the RGB image we can extract only one because the RGB image have a 64-bit RGB image support color plane that the color plane value of red, green, and blue. We can set the which color plane that will we use. Okay, so for this implementation, we use the color green color plane because this is the default. But if you want to use the red or blue, we can change the color plane like this. Okay. After that, we create the case structure to handle for uh, calculation or measurement with the rectangle ROI. So if the start button is pressed and the ROI one is active, okay, so the program will run measurement with the rectangle ROI. So in this step, we need to insert the ROI, vision motion, machine vision, vision utility, region of interest, and region of interest, ROI in convert to rectangle, this one. Okay, and to measure the distance, we can create from vision motion machine vision measurement distance with the clamp horizontal maximum. Okay, for the image we can get from this one for the color extract color plane extractor, and we connect it to the image. And for the ROI rectangle, we put ROI component, and the rectangle that already we set before, we can get from ROI item. So from ROI item 1, we can create the local variable here and change to read. After that, we can connect it to the ROA rectangle. Okay. After this, we can get the pixel. So the pixel we can move here, and we can get the distance. The value is in a pixel, so we can display in a pixel. But we can also convert to the real diameter or real measurement with we can multiply by x divided by y. Okay, we can multiply the pixel, with the xy, create the local variable and change to read. After that, we can move to here, and we can make display to diameter with rectangle ROI. Diameter with rectangle ROI, yeah, like this. Okay. After this one, we already finished to measure the object using our rectangle ROI. So in a diameter with rectangle ROI display, it will show or display the measurement from the camera with a rectangle ROI. And then for the second ROI, we need to prepare the case structure here, and then we move the ROI to activate. If the ROI to activate is tick, so we will measure the diameter using circle ROI. For this, we need circle edge detection. So extract not extract single plane, but maybe I'm wrong for this. This is we can find this one in motion and image with motion vision, located edge, and image find circular edge. Image find circular edge. Okay, so this is image find circular edge. Okay. With this function, we located a circular edge in the search area or in our ROI. So it can locate the intersection point between a set of search line and the edge of the object. So after this, we can connect it output, image output from distance. Okay, we connect to image input here. After this, we will use the ROI item that already set before activate the measurement with a circular ROI. And I will create the local variable and change to read. So this we can transfer to ROI descriptor. And also we need to create we need to properties no, to get the pixel. So create a no breakpoint. Cluster class and variant palette. Yeah, we can right click and or we can no right click, but this one with the circular edge, we right click and set for this one. Okay, we positioning the cursor to the fitted circle and right click. After that, we can find uh, cluster class and variant palette, and we can use unbundle by name. We can set here and we can connect it. So we can choose a radius pixel. Okay. After this, we use the this this is the radius in a pixel. So if we want to know the diameter, so we can multiply by 2 and then can constant 2. Okay. This is the radius. So for the diameter, we can multiply by 2 and we can convert also to the real uh, diameter with multiply by x and y, x by y. Okay, you can create a constant and not constant. Okay, from here, you can click create local variable and change to it, connect it to this one, and we can display in diameter with circles ROI. So for the function already done, and we should uh, we can display the measurement in the image display. So we should overlay the image, the, the source image with the detection of the or measurement the distance of, and diameter. So we need vision and motion image with the image processing. No, okay, vision utility overlay with this one image merge overlay. Okay, and we can drag for the this one image out the first image source, and also we can get from in the beginning image destination. Okay. You can get oh no. Mm, from here. Just grab here. Okay, and we can display to image display for the image destination out image display like this. Okay, and for the false uh, for the false condition, it will no nothing to do. Okay. For the first condition is nothing to do, and it's also same. This, okay, and now we will try to see what the program may on something error here. Tunnel missing. Okay, for the false, we can also set like this. Mm, and then oh, I think mm, mm, okay. I'm I'm wrong. Maybe we should put this. We need to put this overlay here and the image also inside of this, and it will view. Okay, for the true condition, and this is for the true condition. So the output we can match output you can send to the image destination, image source here, here. And then for the image destination, we can use from the camera. Okay, and the machine here is Repeat. Okay, repeat again to the image destination source. Okay, and then for the false, we can create this and anomalous where. Okay, for the this one, you can delete this. Okay, and layer selector. Okay, we can do connect false and false and false. Mm. Oh, we forget to set the start button here. Okay, start button, this one. Session out, we transfer. One image out to the image source and for the here, we, okay, this one. Yes, because we forget to connect the start button to the case structure. And now already done the program, and we can run. Okay, the camera is not connected. So for my camera, I use camera 3 here, and we can start now. Move to the case and capture. So yeah, zoom to fit, click, right click. This is our object, but I should change Nah, like this, because my camera uh, is not work in the first time, so I need to set or configure the contrast. So this is the image. This is the image. So after this, we can create the rectangular ROI and set as a area one. And also for the second, we can create the circle ROI here and like this. And we can set as a area two. After this, we can set the ROI active and capture. So the pixel is 297 and we can calibrate for the real distance is 2 millimeter calibrated. So we can capture again. And the diameter is rectangle. ROI1 is 90, sorry, 19. Okay, but any problem in to show the distance here? Maybe I will check the program or the overlay. Okay, the motor and this. Okay, okay. Hmm, okay. So I run again. This I capture and we set the camera capture and I set for the rectangle here for the ROI and set as area one and for the second ROI as a circle I set as area two and I will capture for the okay, this is the distance and for the ROI active we can capture like this. So the difference with ROI, rectangle ROI and circle ROI is not uh, far. For the rectangle ROI, we can get 21.2. For the circle ROI, we get 21.6. Okay, this is the our exercise with in this video. Hopefully you can do by yourself uh, to use rectangle ROI and circle ROI to make a measurement for your object. Thank you very much.